Hello, welcome to the next episode of Old School Science Demonstrations. Today we're doing a density demonstration that is called liquid flax. Again, if you need to, you can look at the lesson plan located right next to the video and also the demo card. Okay? And I looked at the demo card today to grab all of our materials. And what we need today is some flax. I can show you a bucket here, just an ice cream bucket. And the flax should be non-milled, okay, full seed. And I also have some pinto beans, this one here, okay. These are both approximately, $7 to $10 worth of beans and the flax. And this should last for quite a few years, okay. Set those off to the side. And I also have a baby food jar, one filled with nails, the other one's empty. And I have a couple different types of balls here. I have one that is, it's like a ball bearing. Probably weighs about between 1 pound and 2 pounds. And then I have a ping pong ball. Now in substitution for the ball bearing, you can also use just a chunk of metal. You can go to your local blacksmith, have them cut off a piece of inch steel, and that should also work fine too. Okay, set those off to the side. Now this one here is kind of a neat demonstration. It's almost kind of like a magic trick, okay? And what you do to start this out is you'll have your flax seed, and beforehand, you'd want to take and place your ping pong ball approximately an inch to maybe 1.5 inches below the surface, just enough so the kids can't see it. Now push it down in there, kind of smooth the edge over there, and the ball disappeared. And now I have, in this case, a metal ball I'm going to place on top. And I would say to the kids, I am going to make this metal ball disappear. And I'd place the lid on like this. Now I'm simply going to shake it back and forth. You can lift it up and shake it like this. I found it actually works pretty well like this. I'll give it a few shakes back and forth. And I'll lift this up, kind of take a peek in there. I go, oh man, that's not right. And what you notice happen here is that the ping pong ball came to the surface, okay? And I guarantee the kids will be amazed by this. It also works with the beans. And I'll try it here too, just to show you quick. Seems like the flax works a little bit better though, but I'm going to place this one about a 1/2 inch or inch below the surface and place my metal ball on top also. And we'll give this a few shakes. And what you'll see, it probably doesn't work quite as quick. And we'll open this one up also. And notice again, in this case we have the ping pong ball and the metal ball sank to the bottom. Now I'll give you a couple warnings here. If you are doing this or have the kids do it, and you give it some shakes like this, kind of more up and down vertical, it doesn't work as good as if you go horizontal, okay? So what we're doing is we're trying to introduce air into this. We're actually trying to reduce the amount of friction also within the beans in this case or the flax. Now to help explain this, I'm actually going to shift off over here to the tank. Now I have my metal ball. Now if I ask the kids, actually, what would happen if I placed the metal ball in the tank of water? They're probably all going to say it's going to sink. So I'll go ahead and do that. I'm not going to let it fall, so I'll crack the bottom there. And of course, you notice there it does sink to the bottom. And if I take the ping pong ball and do the same thing, they would say it's going to float, just from the prior knowledge, which it does. Now, to help explain this, I'm actually going to grab the 2 jars here. Now, these are nice for showing density. I've used these pretty much for every density, investigation or demonstration I've ever done, because it's nice to make reference back to these, okay? Especially for the kids that have a hard time visualizing density in their mind. Because density is the amount of mass per volume, so the amount of stuff that makes up something. Now, if we look at these two, they both have the exact same volume. They're taking up the same amount of space. This one, though, is filled with nails. This one's filled with air. So they can visually see a difference. Now, if I ask them, I could pass these around first of all. If I ask them, is this one going to float or sink? They would all say it's going to sink, which it does. Sinks to the bottom. So I know the density of the glass plus the nails plus the lid is greater than the density of water, which is 1 gram per milliliter, also 1 gram per centimeter cubed. Okay? Now, if I take this one here and I place it in there, this one's going to float. Because I know the density of the air plus the lid plus the glass is less than density of the water. Okay? Now the same thing holds true for the liquid flax here. When I take, and I call it liquid flax because it kind of becomes like a fluid as you shake it back and forth. So when I shake it back and forth, the lid on there, even though we can't see it, it acts just like the fluid here, the water. So if I take now the ball out, both of them, and I place it in front, if I say we knew from a prior experience that this ball was going to sink in the water, it went down, this one's going to float, it's no different than if I place them here in front of this container. Okay? I have my heavier ball on the bottom, my more massive ball. I have my fluid in here, in this case by shaking back and forth the flax, no different than the water, because I reduce the amount of friction. I also introduce air. Then I have my ball on top, which is less dense. By shaking it, I actually allow them to separate out into the correct densities, with my heavier ball, my more massive ball sinking, and my lighter ball, which is less massive, coming to the surface. Okay? I want to thank you for visiting the website today. Hope you enjoyed the demonstration. If you have any questions or comments, in the lesson plan right next to this, you actually can email us suggestions for future demonstrations. Also, maybe any things that you would add to this to make it even better. Again, thanks, and I hope your kids will enjoy this demonstration.